Somewhere above your head right now, floating 1,000,000 miles from Earth, a machine is staring into the deepest part of the past. And what it just sent back has some of the smartest people on the planet quietly questioning things they thought they understood for decades. This isn't science fiction. This isn't a movie trailer. This is the James Webb Space Telescope. And over the last few years, it has kept doing something that telescopes are not supposed to do. It keeps finding things that shouldn't exist. Let's be clear about one thing before we go further. Nobody is saying aliens are coming. Nobody is saying the universe is about to end. But what Webb has found is, in its own quiet scientific way, unsettling. Because it is forcing physicists, astronomers, and cosmologists to admit that some of the most basic assumptions about how the universe came to be might be wrong. And when the people who build the models start doubting the models, that is when you know something big is happening. So let's go back to the beginning of this story, because to understand why Webb is causing so much unease in observatories and university departments around the world, you need to understand what it was actually built to do. The James Webb Space Telescope launched on Christmas Day 2021, riding an Ariane 5 rocket from French Guiana. It is the successor to the Hubble Space Telescope, but calling it a successor almost undersells it. Webb's primary mirror is made of 18 hexagonal, gold-coated beryllium segments that unfolded in space like a piece of origami, forming a light-collecting surface, more than 6.5 meters across, over 6 times the area of Hubble's mirror. It sits nearly 1,000,000 miles from Earth, at a gravitationally stable point called the second Lagrange point, or L2, where it can stay in constant shadow behind a sun shield the size of a tennis court, keeping its instruments cold enough to detect the faintest whispers of infrared light from the edge of the observable universe. Infrared is the key word here. Webb doesn't primarily see light the way our eyes do. It sees heat. It sees the stretched-out, red-shifted glow of galaxies so far away and so ancient that their light has been traveling toward us since almost the beginning of time itself. Because light takes time to travel, looking farther away means looking further back in time. And that is exactly what Webb was designed to do, to look back almost 13.5 billion years, to the era when the very first galaxies were forming out of the darkness after the Big Bang. And this is where the trouble started. Astronomers had a model. It's called the Standard Cosmological Model, sometimes written as Lambda CDM, and it has been the backbone of modern cosmology for decades. It describes how, after the Big Bang, the universe expanded and cooled, and how tiny fluctuations in density slowly, patiently pulled matter together under gravity to form the first stars, then the first small galaxies, and eventually, over hundreds of millions and billions of years, the massive galaxies we see around us today, including our own Milky Way. It's a model built on mountains of evidence, and it has passed test after test after test. Then Webb turned its mirror toward the early universe, and almost immediately, things stopped making sense. Within months of Webb's first images being released in the summer of 2022, astronomers started spotting galaxies that were far too big, far too bright, and far too mature to exist so soon after the Big Bang. According to the Standard Model, galaxies at that early stage of cosmic history should have been small, faint, and still in their infancy, loose clumps of young stars just beginning to come together. Instead, Webb was finding galaxies that looked like fully formed massive structures, already glowing with the light of billions of stars, at a point in cosmic history when, according to the textbooks, there simply hadn't been enough time for that much matter to collapse and ignite. Astronomers gave these objects an almost affectionate nickname, universe breakers. It was a joke, but it was also not really a joke, because if these galaxies really were as massive as they first appeared, it would mean that something about the timeline of galaxy formation, something considered fairly settled science, was fundamentally incomplete. Now, here's where we have to be honest and careful, because this is exactly the kind of story that gets exaggerated online. Some of those early headline-grabbing galaxy mass estimates were later revised downward once follow-up observations and spectroscopy came in. Distances that were first estimated using color and brightness alone, a method called photometric redshift, turned out, in some cases, to be less extreme once astronomers measured them more precisely with spectroscopy. Science self-corrects, and that's not a weakness. That's the whole point of the process. But even after that correction, even after the most extreme claims were tempered, a real and stubborn puzzle remained. Webb kept confirming galaxies that were still more massive, more numerous, and more mature than the Standard Model predicted for their age. The exaggerations got walked back. The underlying mystery did not. And it's not just galaxy mass. Webb also found supermassive black holes sitting at the centers of these impossibly early galaxies, black holes with masses millions of times that of our Sun, existing at a point in cosmic history when there simply shouldn't have been enough time for a black hole to grow that large through the normal gradual process of feeding on gas and merging with other black holes. Some of these were nicknamed little red dots by researchers, because in Webb's images, that's essentially what they looked like. Small, compact, intensely red points of light, scattered throughout the deep field images, glowing with an energy that suggested rapidly feeding black holes far earlier and far more common than anyone expected. This is the part where a lot of scientists, off the record, started using words like surprising, puzzling, and yes, even concerning. Not concerning in the sense of danger, but concerning in the sense that a foundational model of how the universe works might have a real gap in it. Some researchers have proposed that black holes in the early universe might have formed in ways we don't fully understand yet, perhaps from the direct collapse of massive gas clouds rather than from the deaths of early stars, skipping several intermediate steps and growing large much faster than expected. Others have suggested that our assumptions about how efficiently early galaxies convert gas into stars might simply be wrong, and that the early universe was a far more furious, far more productive place than the models accounted for. Nobody agrees yet. And when a field this mature, this well-funded, and this rigorously peer-reviewed doesn't agree on an explanation, that's the real story. Not aliens, not conspiracy, but genuine open scientific uncertainty, at a scale we haven't seen in cosmology for a very long time. But galaxies weren't the only thing that shook people. Webb has also turned its attention closer to home, toward planets orbiting other stars, and one particular result in 2023 caused a very different kind of stir, one that reached far beyond astronomy departments and into living rooms around the world. The planet is called K2-18b. It's roughly 8.5 times the mass of Earth, orbiting a red dwarf star about 120 light-years away, sitting inside what astronomers call the habitable zone, the region around a star where conditions could, in theory, allow liquid water to exist on a planet's surface. Using Webb's incredibly sensitive spectrographs, a team of researchers detected the chemical fingerprints of methane and carbon dioxide in the planet's atmosphere, and, more provocatively, hints of a compound called dimethyl sulfide. On Earth, dimethyl sulfide is produced almost exclusively by living organisms, particularly marine phytoplankton. Its presence, even as a tentative and statistically uncertain signal, was enough to generate headlines around the planet suggesting that Webb might have found a sign of alien life. Now here's where we owe you the truth instead of the hype, because that's what actually matters. The detection of dimethyl sulfide on K2-18b was reported at a fairly low level of statistical confidence, and the scientific community responded with a very healthy, very necessary dose of skepticism. Other researchers pointed out that the signal could be explained by non-biological chemistry, that the modeling of K2-18b's atmosphere and possible ocean or magma surface is still deeply uncertain, and that extraordinary claims, especially ones involving the possibility of life beyond Earth, require an extraordinary amount of evidence before they can be taken as anything more than an intriguing hint. The original researchers themselves were careful to frame it as a possible biosignature requiring significant follow-up, not a discovery of life. Later, more detailed analyses using additional Webb data lowered confidence in the dimethyl sulfide detection even further. So no, Webb has not found aliens. But what it has done is prove, undeniably, that we now possess the technology to detect the chemical signatures of potentially habitable, or even potentially inhabited, worlds light-years away, well enough that a debate about the meaning of a single molecule's spectral signature could dominate international headlines for weeks. That capability alone is staggering when you sit with it. We are, for the first time in human history, actually equipped to ask the question, is there life out there, in a way that produces real data instead of speculation? That's not fear-mongering. That's one of the most profound technological milestones our species has ever reached, and it's happening right now, in your lifetime. Then there's the matter of the Sears survey and the deep field images that keep coming back, showing not just individual strange galaxies, but entire structures, filaments, clusters, densely packed regions of early galaxies that appear more organized, more clustered, and more evolved than cosmological simulations predicted for the early universe. Some astronomers have started referring to certain findings as challenges to the standard model rather than mere anomalies, a much stronger and more serious label in scientific language. When a result gets called an anomaly, it usually means we'll figure it out with better data. When it starts getting called a challenge to the standard model, it means we might need to change the model. There's also the strange behavior Webb detected around the so-called Hubble tension, a long-standing disagreement between two different methods of measuring how fast the universe is expanding. One method, based on observations of the early universe in the cosmic microwave background, gives one expansion rate. Another method, based on measuring distances to relatively nearby stars and galaxies in the present-day universe, gives a noticeably different, faster expansion rate. This discrepancy has existed for years, predating Webb, but many scientists hoped Webb's precision would resolve it by confirming that one of the two methods contained a hidden error. Instead, Webb's more precise measurements, if anything, reinforce the disagreement, adding weight to the unsettling possibility that the tension is real, that our understanding of how fast the universe is actually expanding contains a genuine unresolved flaw, one that might require entirely new physics to explain. Some researchers have speculated this could point toward unknown forms of dark energy, unusual behavior of dark matter, or physics we haven't discovered yet. Nobody knows. And a mainstream scientific community collectively admitting we don't know about something as fundamental as the expansion rate of the universe is, frankly, one of the rarer and more significant moments in modern science. It's worth pausing here to appreciate just how strange this all is from a historical perspective. For most of the 20th century, cosmology moved in careful, incremental steps, big paradigm shifts, like the discovery that the universe was expanding, or the confirmation of the Big Bang through the cosmic microwave background. Happened maybe once every few decades, and even then, they usually took years of accumulating evidence before being widely accepted. Webb, in less than 4 years of operation, has produced enough unexpected results to spark multiple serious debates about the foundations of cosmology simultaneously. That pace of disruption is genuinely unusual, and it's part of why so many working scientists describe this moment as one of the most exciting, and yes, occasionally unsettling, periods in the history of the field. None of this means the sky is falling, and none of it means the universe is broken. What it actually means is something far more interesting. That we built a machine so precise, so sensitive, and so far beyond anything that came before it, that it is outperforming our theories. It's not that the universe suddenly changed. It's that, for the first time, we have a tool good enough to reveal how much we still don't understand about it. Every impossible galaxy, every unexpected black hole, every disputed biosignature, every widening tension in the expansion rate. These aren't signs that science has failed. They're signs that science is working exactly the way it's supposed to, by running headfirst into the edges of its own knowledge and forcing itself to grow. Scientists don't get scared by discovering they were wrong about something. They get excited. What actually unsettles a physicist isn't a strange result. It's the absence of strange results. A universe that behaves exactly as predicted with nothing left to explain. Webb has handed cosmology the opposite problem. Too many puzzles arriving too fast from a machine that was only supposed to confirm what we already suspected, and instead keeps tearing pages out of the textbook. So the next time you see a headline claiming Webb scared scientists or broke the universe, know the real story behind it. It's not about fear, it's about humility. The growing realization among some of the most rigorous, most skeptical, most highly trained minds on the planet that the universe is stranger, older, faster, and more mysterious than our models accounted for. And somewhere out there, a million miles from where you're sitting right now, that golden mirror is still open, still cold, still patiently collecting photons that have been traveling toward us since before the Earth even existed, waiting to tell us exactly how much more we still have to learn. That, in the end, is the real story of the James Webb Space Telescope. Not a monster in the dark, not a warning sign. A mirror, literally and figuratively, held up to human knowledge itself, showing us, with stunning clarity, just how much of the universe still remains unexplained. And if that doesn't give you a chill down your spine, nothing will.